Good morning, friends, and welcome to Eason Academy. And we are discussing about understanding the 8085. And today is a week 2 and session 1. And today, last week, we discussed about the 8085 pins. But if you're not understood, don't worry. We will discuss in depth later when we make a small circuit diagram and we'll make a 8085 based system design. Okay. How do we connect the chips and how do we interface them and how do you make a real board using 8085. And let us start with the 8085 instructions. See, all this 8085 to every microprocessor was slightly complex in one way, not a complex ways that if you don't know basic hardware or the pinouts, you don't understand the instructions. You don't understand the instructions, then you don't understand the hardware. So it's a complex in a way. The way is that you need to be balanced. You cannot go without knowing 8085 instructions or programming. You cannot do anything in the hardware. Same way, without knowing the 8085 hardware, it is slightly difficult for you to understand 8085 instructions. That's why the last class, I have given a small idea about how the 8085 pinouts are. Okay, for example, we have discussed about the chip, how it looks like, and we discussed about what are these 40 pins of the chip, the address lines, and then about SID, SOD, reset, and ALE, read and write. Okay, so we compared with the regular processor, how it works. And today, let us understand about 8085's own language. This, even though this looks to be like a small chip, it has its own brain. Only thing is the brain cannot think. This brain can only do the work. And he knows how to do things. But what are things he do it? That this manufacturer, for example, this one is manufactured by Intel. So he given a set of his capability that you should understand. If somebody don't know multiplication, if you ask them to multiply, they cannot do that. So you should know the capability. So let us get back to the understanding 8085 instruction set. Let's go to the board. So as usual, we go to the board. And anytime you can stop me whenever you don't understand. Okay, so we are doing something to avoid the lag of things. Let me cut down my video. This solves the little bit problem of lagging. Okay, see, before we proceed to discuss about 8085, let me tell you one thing. All microprocessors, including 8085, all microprocessors can do only one thing. They give address, they give read, they give write, they give or accept data. That's what they can do with the external world, nothing else. That's why it's becoming like a black box. See, the initial days, people are confused with electricity. Because till that time, people are using mechanical. Before that, it was physical. You saw objects. It was very easy to understand mechanics. When we came electrical, people get confused. Then they were much more confused when it came electronics. Because you are controlling what you don't see. You don't see the electrons, but you are controlling the electrons. Oh God, everybody has got confused. How can it happen? Because when I do mechanical, when I do physical, I saw everything. For example, there is a water pipe. I control it. I see here, physically there is a gap, the water is not coming. But when it comes to the electronics, how a transistor, I get a physical part, 3 pins. I don't know how is he doing it. Nobody understands. That's why the electronics was always a fussy one. The biggest fussy in electronics is the microprocessor. Okay, he start behaving like you. He start performing all the operations at a remarkable speed. That's why we generally call instructions per second. Please understand, this 8085 program no time limit. I want you to understand very thoroughly the whole thing, because if you put this base correctly, later when you discuss about 8051 or ARM or RISC-V, all will be easy. If you don't discuss this properly, then everywhere we have a problem. So I will take slightly more time than my typical classes. I will go very, very slow, such a way that everything you understand. The instruction per second is a very important. For example, this microprocessor can perform addition or subtraction. 8085. How many additions he can do in a second? That matters. How many additions he can do in a second? That matters. Okay. Here's a small trick that is internal, that is decided by your signal called clock, and also how fast the clock is. Nothing but on off. In 1 second, how many on off you're doing it. That's what exactly it matters. Okay, now that is the internal to the system. But the external to the system is microprocessor can do only 2 operations. It can write or read. But for that, he is using these lines. The trick is your memory could be so big. That depends on your size of the address. If 8085, you have a 16 address lines. That means that I can start from 0000 to FFF. That means that 0 to 65,560. 65. Am I right? 2 power 16. 535. Sorry. 65,535. So this is what your decimal. This is what your hexadecimal. That means that this microprocessor can write in all the locations. He can read from all the locations. That's what is possibility. That is what you can do. You cannot do anything more than that. The another beauty is from the 1970 till today, 2021, all the microprocessors, they perform the basically processing. That's why they call microprocessor. What is the processing? Addition, subtraction, multiplication, division, so many things. But this is a very primitive process. They don't have multiplication and division. They have only addition and subtraction. But this guy has a small unit to do the process. That is called ALU. We'll discuss later. What is that? But the ALU has a problem. That's why you have a problem. The problem is these things are very easy. You should know the limitation of this guy, this 8085. What is his limitation is this ALU will do the operation only with this local small memory. Like this. But this is very small. And this is called register. Register is nothing but a small. Let us take how a human being do that. When I write now 5 plus 3 equal to how much? What you do? You read the 5 and put it on your brain. There's a memory in your brain. In your brain. Oh, I don't have a space. In your brain, you have a space called frontal lobe. And there's a place called temporal lobe. There, you read the 5 and keep it here. You read the 3 and keep it here. Then you perform the operation and put it here, 8, and write it back, which you don't know. Normally, the brain does the operation only within the brain, not outside the paper. What your eyes or hands or ears are doing it, getting it from outside and putting it in your brain memory. Then the operation is taking place within the brain. The same thing they copied here. Here also they call registers. Okay. Not to here the memory we call 0 to number. Not to confuse with this. They call this as a register and they given a name for everything. In 8085, they given a name called start with A, B, C, D, E, H, L. Okay. Like that they given. So here is one important information which you need to understand. That is what the trick. The trick is when the 8085 microprocessor writes something to the outside, he uses the data bus to give the data out. Let's say I want to write 55 at location 1000. Okay, what this guy will do he put 1000. What is 1000? It is nothing but 16 address lines. So everything is physical. I have a 16 address line means 16 wires. When I put /60 means 16 wires. And all the wires, I'll drop it here, slightly write it. All the 16 wires. I don't like to draw big. That's why I write it so small. So we call A0, A1, like that up to A50. Because we start from here. That means that between the microprocessor and the memory, there are 16 wires. The problem is, the moment you write, when the microprocessor gives 1000, that means that is an hexadecimal. I put 0, 0, 0, 1. That is 1. Then 0, 0, 0, 0. Then I write 0, 0, 0, 0, 0, 0, 0. One more 0 is gone. Okay. Then 0. Am I right? So, see here. You make it as a group. If you make them as a group, then you will understand. This is 1. This is 0. This is 0. This is 0. This is what actually happening. 0 means 0 volt. Actually, everything is voltage. 1 means 5 volt. That means that the microprocessor is giving this through wires, these voltages. Please understand. This is what address means. What is possible is all of them can be 0 volt. That means here 0, 0, 0, 0. That is what I have written short like this in hexadecimal. And this one is 1111. This is the biggest. No, effectively what I'm trying to convey is different. Sometimes I have to deviate and tell these things because you might have forgotten or some reason where I've given you the ideas. So there are all two chips. They communicate through wires. And these wires are called address wires. Based on the combination, this microprocessor tells that guy, memory, what to write, where to write, that combination here. Then he gives a signal called write, whether it is write or read. Everything is through wires here. Not like we have so many things, man. We have mouth, ears, hands. We want to call somebody, you say, come here. Or sometimes we say clap. We do so many things to call a person. But here, things are different. Everything is through wires. And every wire is having a special name. Okay. No, why I've come here is, when this ALU, the microprocessor wanted to write here at 1000 at data 55. 55 means I have 8 wires. I have 8 wires. I have a data is 55. 01, 01, 01, 01. That is 5, 5. Understood? I've written 5, 5. Now, this data has gone from microprocessor to memory. The trick here is this. The trick is that understand the trick. That is what I've tried to. I've exactly tried to convey this one very important information. That is, I've written 55 at 1000. Who is doing it? Microprocessor. Microprocessor to memory. That is based on the clock. If you assume that the clock is 1 megahertz, then the timing is 1 microsecond. The timing is 1 microsecond. When the timing is 1 microsecond, first, what microprocessor does? First to 1 microsecond, he gives 1000. This guy got it, but still he will not accept. The second microsecond, I am going to give a signal called write or data, 1000, that's 55. And third microsecond, the third microsecond, I am going to give write. Now the memory understands, oh, our microprocessor want to write. Okay, so he write at 1000. So please understand, when I go from microprocessor to memory, it is the responsibility of memory to store the data. The reason was, afterwards, after the 1 microsecond, I will remove the address, I will remove the data. I will start using, next time, I will try to write 1000 and 2000. I write 76. Now, I have written 55 now. It has gone out of the wire. So, when the microprocessor write into the memory, it is the responsibility of a memory to store it. Okay. If the memory don't store it, then the data is gone. That the wire is used for only temporary. Please understand, the wire is used, data wire is used for only temporary. So, when the microprocessor gives, it is responsible for memory to record it or store it or latch it. Same way, when the microprocessor give read as a 1, I give 2000, I give read as a 1. What is happening is, in the clock, microprocessor gives first clock, second clock, third clock. The first clock, the microprocessor gives 2000 address, 1 microsecond. The second clock, the microprocessor gives read as 1. Done. Read as 1. Write as 0. Now, the memory knows that microprocessor want to read. So what the memory does, at line 2000, you are having 76. He gives 76. He gives 76. Now, this is a trick. You need to understand this trick. This 76 coming on the third clock. That is how much time? 1 microsecond. Afterwards, after the 1 microsecond, this microprocessor will use this address line for another address. He may write at 3000 some other data, 21. Okay. So the 76 is gone now. Now who has given the thing? Memory. To whom? Microprocessor. It is whose responsibility? It is the responsibility of the microprocessor to store it here. Where to store? That is what we have. We have a register. When I tell you that I add 4 plus 5, fine, I have told. It is your responsibility to remember. If I tell you that add 43 plus 26, done. I will not tell you once again. You have to remember what I told. For that, you have a small place in your brain, a small memory to store it. In microprocessor, that memory is called register. So please understand the function of register. It is for two purposes. One purpose is when I am trying to read from memory, I'm here to store it. Okay. Because the microprocessor have to store somewhere. That is what this. They are nothing but a small scratch pad memory. Like you store it like that. Then second most important thing is this process that is in your brain. It is called frontal lobe. Which perform the addition, subtraction, everything. It does everything from where? For example, I told you 23 plus 45. If you forgot 23, you're gone. You cannot do that. Am I right? Like that here, the frontal lobe is having a small memory where it stores 23 and 46. Here, that is stored here. This process, we also call this as a ALU, arithmetic or logic unit. In this case, he does only two operations, addition and subtraction. This microprocessor does not do multiplication or division. This ALU does not have. Same way, logic and or not and XOR. It performs this operation. Okay, normally this is not, it's there, but let us have only and or not. That's what generally is the thing. So this guy does the process, but only trick is all this guy process or with respect to only this guy. The ALU is totally shielded from the memory. The ALU does not know about the memory. ALU takes everything from the registers. Now, let us come. Now, let us forget about the memory. What they have done was, I have so many registers. I call A, B, C, D, E, H, L. Let us take what it is. Some names. You may call this also R0, R1, R2, R3, R4, R5, R6. But 8085 they called it as A, B, C, D, E, H, L. All of them are nothing but 8 bits. All of them are 8 bits. Now let us assume that everybody is having some values. How the value come in, we will discuss later. Now let us have some values. some value. Some values are there. Now, there is somebody called the microprocessor control unit. That guy is all about. And we discuss about ALU. Now, forget about ALU now, temporarily. Now, let us now discuss with these two people. The control unit accepts what? 8 bits. That 8 bit is called instruction. Call 8 bit is called instruction. That means that since I have a 8 bit 000 000 up to 1111. That means that our control unit accepts up to 0 to 255, the maximum of 256 instructions. Or you can call it as a command also. Both are same. Command or operation, whatever you call. Instruction or command or operation, all are same. Now, let us discuss how we are giving it. Now let us give it everything. This guy is having a flexibility in 8085. In 8085, this is all in 8085. They said that you can move from anywhere to anywhere. Understand? You can move from anywhere to anywhere. That's a trick. That means that I can copy A to E. I can manipulate. I can move from L to C. I can move from B to H. I can able to move the data within this. We actually copy, we don't move. Copy is different, move is different. Move means we remove it, that becomes 0, 0. I don't move, actually I copy. But somehow they called us move and we are calling us a move. Move from where to where? I want to move from E to A. Understand? There are how many combinations are there, you think? Okay. We have A to B, A to C, A to D, A to E, A to F, A to H, 7. Like that, B to A, B to C, B to D, like that, B to HL. Remove the F, sorry, no F. 6. But they have also given one more extra. A to A is possible. A to A is possible. I'll explain to you later why you have a to A. I move this itself to here. You will find out what is a use. But there is a use. Same way, B to A, B to B is also there. I have like that H to H, L to L. There are how many instructions now? Tell me. This is the way we go about. Normally, what we do in the processor, what he can do, we understand. What he can do here is he can manipulate things. Okay, he'll be able to move the data from his own memory from anywhere to anywhere within that. You cannot do that. That can be done by only control unit. If you tell him a number, then he will do that. For example, if it's 0, 1, 0, 1, 1, 1, 1, 1. For example, let us take. Let's say 8 bit. Let us assume. What I've written here, what I've given him now, 1, 0, 1, 1, 1, 0, 0, 0. That means that he will understand who? Our man. He understands that, oh, Balaji wanted to move this from B to A. Am I right? This is called instruction, opcode. That's what we call operation. like instruction, other meaning called operation. Who has given this? If you go to 8085, instruction set, that they have given this. Okay, let me see whether I can, you can see it also, but I will try to share it. I'll show you the thing. It's like I'm doing like you exactly how you do that. Just such the web. Sorry, here they don't have a opcode. I'll do other one. Yeah. See here. If you see here, let me. You are watching the screen. Is it visible? Let me try to open it in the this one. These are all, see, I cannot logically think. These are all given by the 8085, which I cannot remember. I do not have to remember also. Please understand these things. Once I was remembering, when I was in college days, I used to remember all the 250 instructions. Okay. See here. Can you see that now? See here. Every instruction has been given a special code here. This you will get it. You will get it. Google search everywhere. Am I right? Nothing great about that. It's all given by 8085, the Intel company. Everything. You see that A, B, C, D. But forget about this M. I'll explain later. Okay. So there's somewhere something will be coming in between. Don't worry about that. Okay. So if you see here, if I give this, for example, let us see here. Oh, B, A is 47. I have given wrongly. Okay. So A, B. I told A, B. A, B is 78. Okay. So I've given different letters here. I've given 78. Let us use 78. That means that if we give 78, then our control unit understand what is that in he understands move A, B. Understand? Now, since A, B, B to A, that is what 8085 convention. This is called move source to destination. So I'm moving from source to destination. Sorry, I'm writing it on a board. This is enough now. I can stop this. I just wanted to show you that. That's the only thing. So if you say that move A, B, you are trying to move C. Please understand, this 8085 has about around 250 instructions. Okay. 246, 47, 50 or something. You should know thoroughly all. The thing is that at least you should know that how each and everything works. Finally, you know that you have a satisfaction that I know one processor thoroughly. There's nothing in it that will help you out. That will help you out in the long run. That is what I'm trying to give you. You know that there's a concept called divide and conquer. I am trying to take the easiest one. We will execute these instructions. What is that? Am I right? Now, when I do the 78, if I give it, then our man understands who? This control unit. You want to move AB. Then he is giving a signal here. Move from here to here. Those things are local connection. Don't worry about that, how the signals and everything. That means that how many things here? I have about 7. 7 to 7. 49 instructions are done out of 250. Now let us take how this microprocessor execute the instruction. Let us take 78 itself. Move BKMI. That is a trick. You understand one instruction, then you will understand. Now, this is a microprocessor. And he gives the address. The moment you give a power on, 5 volt, the microprocessor address 0000. In your memory, the first line. Also, microprocessor always do read. It does always read first line. He does not do write. He always do read. So read as a 1 and write as 0. Then data line. Now he's going to read now. He's going to read. Now, on the first line, you stored 78. You stored 78. Forget about how you stored. You stored. Right now, let us say that inside the memory you stored 78 because you have written. You went to the data sheet. Normally there'll be one confusion will be there. That confusion I'll explain to you later. How do you do that? How we did it, how you do that. 78. You store it here. So in your data sheet, instruction set of 8085. They have mentioned move A, B. That means 78. So this no assumption. This and all you better follow. Don't assume anything. When you want to create your own process, you give different number. This number is given by who? That 8085. That is Intel. That better follow that. Now you put the 8085 here. Now you give a power. You have a switch here. You on the switch. When you on the switch, the microprocessor gets 5 volt. Then he gets the clock. When he gets the clock, then this microprocessor will put the address 00 first. Then he gives read second. 0 second. These two same activity. Microprocessor can do either read or write. It cannot do simultaneously read and write. It is not possible. Now, this memory 78 comes here. Here. But you have a control unit. The control unit use the 78 to understand. But I told you a very important one in the beginning of the class today. This microprocessor clock, there are 3 clocks. Each, let us assume that 1 megahertz. So this is 1 microsecond. This is 1 microsecond. This is 1 microsecond. So this guy gives 78. That will come here for 1 microsecond. Afterwards, I remove the address, that 78 will go off. The next clock, 78 is gone. Only during this clock, 78 comes. Then afterwards 78 is gone. If that microprocessor don't remember that, it cannot execute the operation. For that reason, they have a small memory here. I told you all the memories inside the microprocessor, we call them as a register. Now tell me, what is the purpose of this register? This register is storing the thing which is coming on bus, and it does not store everything. It stores the instruction. So we call this as the IR, or we call it as a instruction, nothing but a latch. There's nothing but a latch. And this goes to control unit. So the advantage is, this is not known to you. This is not known. You cannot use latch or IR or anything. This is done by the microprocessor. So the moment you switch on the microprocessor, he gives address 0, and the 78 comes from the memory to microprocessor, and the microprocessor latches the 78. Understand? Then it performs the operation. Then it is giving the instruction to the control unit, giving the instruction to the if you want later, I'll one day at the end of the day, I'll explain to you all these things also. How exactly the control unit is taking 78, how he is performing. I know in and out of the microprocessor, how it is working. I can tell you the exactly what is happening inside. But right now, we are having a bird view. Don't get into the system. You are a driver. Don't try to understand that how the engine works. When I press the accelerator, then you will never be a driver. Now let us be a driver. Let us try to understand the car. The manufacturer told you that if you press the accelerator, car will move. You move it. That is what he told you, that if you give 78, I will perform the operation. What operation? 78 means move B, A. That means that there are 3 registers. The B is having 71, and that goes to A now. Whatever A is gone, it will not be saved. Once you have done an operation, you cannot retrieve back. What was there previously? Previously, A could have 55. The 55 is gone now. If you move B to A. Okay. Now, let us assume that 79 means move C to A. Let us assume that. Let us say C is having 45. Now you put it on second instruction. Now, after this control unit completes the first instruction, he moved to 71. Then he will go and change the address to 1. I'll tell you next how it is happening. That is a subsequent thing, slowly. Now we try to understand the very top level functionality. Now this 1, then he gives read and write as 0. Then 79 will come here. Now 79 will be latched here, where in IR. The 79 coming for the database is latched. Now the control unit understands, oh, Balaji want to move from C to A. So he will move 45 to 71. The 71 is gone now, 45 is. This is the way you, first of all, write the instructions and do this. Okay. Now, let me stop here. If you have any doubt on moving I told you that this 8085 is having about A, B, C, H, L, sorry, D, E, H, L. For everything, there is a number. For everything, there is a number, which I've shown you in the previous sharing. For everything, for every instruction, there is a special number. There is no common number. If you want to move from L to H, 65. You want to from H to D, 54. So this guy, control unit, understand every number which he has given you also. These are all the things which I understand. Understood. So let me know if you have any doubt on this. If you don't have a translator, then you have to do that. Let's say, for example, I'm going to Delhi. I know only Tamil. I don't know Hindi. Understand? If I have to speak to you, you know only Hindi. I have to speak to you only Hindi, better I learn it your language because I have to speak to you. Same way. No, they have not dropped. This is one thing I'll show you. I'll write you. They have not dropped actually. They have not dropped actually. They have, this F is there, but they given us something called, I'll explain later, that is called flag register. And FG is the combination. FH, GH not good. So they put AB, BC, DE, then F is not there. So they remove G also. Then they put HL. It is like what do you call? BC, DE, HL, becoming a nice rhythmic pair. That's why they use it. Okay. And that's the, since F is not used, F is called flag register. I'll tell you what is the use of flag. Okay. So please understand, we did it. Let me tell you, even in the colleges, when you're doing the microprocessor lab, you do the same thing. The thing is that they will give you the microprocessor box. They will have 8085 and you have a display and you have a keypad. So what you will do, you will write the thing in assembly, then you convert it to machine code, opcode. Then you have to, so you should know the opcode. In that case, if you are trying to do with direct, if you're going to interact with the microprocessor directly, then it is your job. One day is no other way. I told you an example. I go to Delhi. If I have to talk to somebody, I should learn Hindi. Am I right? But suppose I go with my friend who knows both Tamil and Hindi. Okay. I will tell him, hey, buy this. Then that guy will buy the, tell him in Hindi and get it. I do not have to learn. If you have a luxury enough to take somebody with you, that's why we call translator. Or we call, here it's called assembler. Assembler is a software. Actually, you will write as a part of this course, embedded system programming, you yourself will write a software called assembler, which will take the instruction set and convert. A lot of people have written. Already a lot of people have written that in the group. There are two things you will do. One is you will write the translator, which will convert the, let's say I take a file. I open a file, abc.asm. If I write here, move A, B, move A, C, move H, L, everything I've written. I close the file and your assembler program take this as the input and it will give you the file called abc.bin. That will have 78, 79, some 56 something, whatever it is. You will write it as a part of the course. That time you will understand thoroughly what is assembly language, because you are writing. You don't, you make it, you, let's say that you write a dictionary. You write a dictionary from Tamil to English or Hindi. That time you will understand Tamil and Hindi. Like that. When you try to do this assembler, you will understand what all the 256 is. That's why I wanted you to write it. There you get a lot of advantage. One, you learn the programming. Second, you learn how to write an application which somebody can use it. Somebody can use it. You should never write it and give it to your friends. Third one is you understand the 8085 assembly language. But please understand, all the assembly languages are same. Only thing is, as long as you are not afraid. As long as you are not afraid, if you don't have a fear, if you remove your fear, this microprocessor is nothing. If you think that microprocessor is great, you have gone. The moment you think the microprocessor is great, you have gone. Let me be honest. This is nothing. Hey, somebody manufactured, given a sheet, he is going to do that. If I give that, he will do that. That's it. Only that respect you give to microprocessor. Don't give more respects. The only thing is, he does the operation at very high speed. That's the only thing. He does a very small operation, moving from here to there. Anybody can do. You can also copy it. But the only thing is, he moves the things at a very fast speed. Maybe 1 microsecond, 1 nanoseconds, like that. No, that is totally done by this guy. Please, that is a very good question. Somebody has asked. Okay, see, now there is somebody called a register or latch, which is coming from the data line, this 78, which is latched here. Okay, and the instruction goes to only control unit, not to anybody else. It goes to only control unit. No, please understand. Move A comma B, it will do what it will give. What is not there? There is a latch. They are nothing but registers. They are latch. The latch, as soon as you power on, as soon as you give the 5 volt, the latch will have some data. Could be XXX something. You don't know what it is. Till you write. Next we are going to discuss how do you write. Now the question. Now I'll try to answer the question. Now I don't know on power on. Please understand. On power on, this microprocessor has a registers. They are all junk. You don't know what is inside. Because I told you that the flip-flop, the moment you give a power, the output of flip-flop is always don't care till you write it. That is called volatile memory. These are called volatile memories. They don't remember. The only way you have to do operate thing is you have to do that. Now let us assume that. This is a trick here. Here is the beauty. I wanted to do now move A comma 75, some data. I want to move some data to A. I want to move B to some data. But our man, Intel, they wanted to tell you something different. That is, when I say move means register to register. So they call this as a move immediate. Move immediate. Same move only, they call it differently. Let us say move immediate A. For this, the instruction is 3E. Okay, let us go there. Let us go and see that temporarily. Let's take time and do the thing. It doesn't matter. Here you see, move immediate. A means 3. See here. Now, this 3 I have written here. Okay. Now, I have to move what value? 75. I write here 75. What this guy will do? Who? Our man. I have to change this thing a little bit. I'll do it after second class. The second class, I will do it slightly different this one. Okay. Now, I have written 3E and 75. I converted. This is 3E as per the instruction set. This is 75. This key will give address 00 the moment you power on. Then he gives the read signal. Write a 0. And data, he gets its 3. The 3 goes here. This is called instruction register. Now the 3 goes here. Okay. Now the control unit understand you want to do what? Move immediate to A. Understand? So here is a trick. So then he knows that he has to take the next data, the immediate data also. So he'll give, the control unit will give a command and make it as a 001. How he is giving, we'll discuss later. There's something called PC is there. We will discuss about what is PC later. Now the 01, it goes here, read is 1, write is 0, then I get now 75. But the 75 is not the instruction. So what will happen? This control unit will latch this to another register called temporary register. It's not visible to you. You don't know these things. He's putting on temporary register. The 75 comes here. Okay. They have, I told you, A, B, C, D, E, H, L, and F for flag. Apart from that, this guy had 2 more registers. We don't know W and Z. You don't know that. They are there. You cannot use them. They are there for his usage. One of them is, let's say, W. He stores this 75 here. So understand, he stores 35 as an instruction and he goes 75 as a data operand. Operation operand. Done. Now, done. Now, he knows that 3 is moved A. So what will happen? This 75 will be returned to A. It's clear. You don't know this temporary, there is somebody is called W. Actually, what you are doing is you are moving to W, that W2, that's what's happening. But you don't know, you don't see that. There's a small in between temporary register is there. Only he is executing, he moves a 75 to that. Till that time, it is there on the temporary register. Okay. We will discuss thoroughly all these things. I'm not, this since you asked, now what happened? I will do same thing, move immediate B. That could be 06. I want 91. Now the controller will give a command, it will become 02. It will go one by one. Then 06 comes here. Then our controller will understand this 06 means I have to perform move immediate B. Then he will give the instruction to 3. Then 3 goes here and 91 comes here. 91 is saved here. Done. This is called fetch instruction. That means that I have fetched the instructions and stored into my local memory. Now, our man who control unit will do the execution. When he is executing, he knows that, oh, 06, move immediate B. Then he will take the output of this one and he will put on the B register. A is over B. On the B register, he'll put this 91. I told you, this is not the final day of the class. This is the first day, second day. So you will slowly, aram se understand. Okay, don't worry about that. Whatever you doubt, ask me. Don't hesitate to ask your doubts, because like you, others also will have a doubt. And this is very critical. Otherwise, I could complete the whole class in one hour or 2 hours or in 5 hours or 10 hours. But in this class, I do not have time limit. I do not have upper limit. It will go till you understand. Whoever they say, I've understood, don't attend. I'm very clear. I will take the class such a way that I want the last person to understand. Try, but if you don't understand, you put the effort. Try to understand. The trick is very clear. Why I am taking so much of pain to make you to understand for long, even though if it extends on Sundays, I don't mind. The reason is, this is a trick. By chance, if you understood this perfectly, that's it. You understand the embedded system, you understand ARM, you will understand computer architecture, everything you understand. The day you understand 8085 instruction set thoroughly, that's a day. That's a day, man. I'll bet. Oh, so please, there's a confusion. We use only flip-flop only. It's called latch. No, don't confuse with the. This is nothing but this latch. Oh God, this is another, which I think you have. This latch is the nothing but D flip-flop only. We are calling it as a latch. Don't confuse with RS latch and RS flip-flop. That is gone. Okay, this latch is different. Okay, this latch is. They have a lot of confusion, man. This latch is nothing but D flip-flop only. This latch is D flip-flop only. No, you have not attended. That's we'll discuss later clock. That is done by the other embedded system programming class. The problem is like this. It has to come like this. 8085 is a microprocessor. So first of all, you have to understand what is microprocessor. Then come to 8085. Okay, you attended the class enough, and I think you're not done the microprocessor class yet. After that, you go and see the videos, you'll understand thoroughly. But now, whatever it is, have it, listen, and it will go into your brain, and it will store somewhere. It will be useful later. Okay, don't worry about the confusion. I think you have not attended the other. You are not part of embedded system programming class 1 or class 2. That we have explained about this clock very clearly. Okay, not very clearly. We told what is clock. That's the thing. We are going to discuss about clock and everything in the analog classes. Don't worry about that. Yes, actually, yeah. For you people, tomorrow is the first class. Okay. For the embedded system 3 weekend class, tomorrow is the first class. Okay. So let us have a small break. Okay. And in the meantime, think of these things. And I'll leave the other sheet with you. And instead of this, I will do the other one. See that the instruction numbers, then you will get an idea that you also do this. Whether I do it or you do it, the Google is going to give you the same thing. Don't worry. Oh gosh.